Good morning, everyone, and welcome to the webinar. My name is Jennifer Adelstein, and I'm the Marketing Assistant for Industrial Controls. Today's webinar is Pneumatic Actuators for Valves and Dampers. This is the third webinar in the pneumatic series, which followed part 2 on thermostats and controllers. The presentation will take about 45 minutes, and after, we will take some time to answer your questions. During the presentation, feel free to enter your questions into the chat interface on the right-hand side of your screen. We will also open it up to voice questions where you can raise your hand, but this option is only for people with phone connections and not those using their computer microphones. Now I will introduce our speakers. John Graham is a senior engineer at Industrial Controls and has close to 30 years experience in the industry. In that time, he has worked with mechanical contractors and industrial and commercial customers selecting discrete components and designing HVAC and industrial solutions. Pneumatics and combustion are two of his many areas of expertise. John did his undergraduate work at the Milwaukee School of Engineering. Our second speaker is Carl Johnsen, and he is a commercial distributor rep for Honeywell and has been with them for 37 years. Carl was previously a new construction technician, service and installation manager, and a national accounts manager. Carl graduated from the University of Illinois with a BS degree in industrial education. Carl has his FAA, Airframe and Power Plant Mechanic license, FCC, first class license with ship radar endorsement, and is a certified energy manager. Now at this time, I will pass it over to John to get us started. He and Carl will be alternating comments on each of the slides as we move through the presentation.
Thank you, Jennifer. Welcome back, everyone, to this third session. Carl and I here again. We had shared a little bit on air stations in the first session. Second session talked more about the thermostats and relays and devices that operate between the air system and what we're talking about today, which is damper actuators and valve actuators. We're going to talk about actuators for valves and dampers, of course, spring ranges, how these are selected for sequencing operation, difference between normally open and normally closed valves. We'll touch a little bit on three-way valves and wrap up with damper actuators and how they are linked and selected, spring range, all that kind of stuff. So really we're kind of completing the loop, if you will, between our air supply and the controllers that control these devices and these being the final control devices in a typical pneumatic system.
I'm going to try and advance the slide here, John.
Okay, thank you. So the first image you see up on your screen is a picture of a pneumatically actuated, normally open valve. And you'll see at the bottom we've got a globe valve body. And above it is the actuator and spring and linkage. This is typically shipped as one piece, but quite often can be serviced as individual pieces, being the linkage, body, and actuator. What you'll see at the top is the branch pressure line, which admits air from your branch device, be it your thermostat or your receiver controller. That air fills the chamber above the rolling diaphragm and pushes down against the spring, which ultimately actuates the valve stem, which operates the plug inside the valve body. The valve that we're looking at here is normally open, which means in the absence of air pressure, the spring is applying an upward force to the spring cup, which ultimately pulls the stem and plug up. Valves can be normally open or normally closed. Valves can also be provided in a three-way configuration, which essentially has a plug between two seats. So as the stem goes down, it closes one plug. As it rises, it closes the other. But again, what we're looking at here is a normally open pneumatically actuated valve.
On the maintenance side, John, we've talked a little bit about before, just to share what your experience has been, that these bladders that we talked about here can be easily replaced on a lot of these devices where the top can open up and unscrew out, right?
Exactly, yeah. The wear parts, of course, because the diaphragm is in continuous movement, the edges will eventually crack, they'll dry up, so it's not a real big deal to remove the top and replace the diaphragm. The other thing that can happen through time is the actual bonnet and packing can begin to leak and wear. So many manufacturers do offer renewal kits that provide essentially a new stem, new packing, so you don't need to necessarily replace the entire valve. You can just replace the parts that have failed. Very simple to service, very dependable design.
Okay, let's see if we can move on to the next slide. one is for you also, John.
Okay. Okay. We talked briefly about valve bodies, and we're going to talk about valves first and then damper actuators second. But depicted on the left is a normally open or direct acting valve. And by that we mean as the stem is driven downward by the actuator, the valve closes. The one on the right, although it looks like parts of it have been missed, that is a reverse acting valve. If it were all there, you would see a plug that is actually below the port. So as the stem is drawn upward, the valve closes. The normally open valve is typically called direct acting. The normally closed or stem up closed valve is called reverse acting. The three-way valve on top, it's maybe perhaps a little hard to see, but actually no. Now they see it better. It looks like it's a two-way valve, normally closed. So that would be very similar to what you'd see on a three-way with the port on the bottom.
Okay. Advance to the next slide. The control of the two actions with either a direct acting or reverse acting actuator will then give us our final control configuration. So you really don't know what that is until you add both and look at the combination of both the actuator and the valve together. So right now, John was just talking about the valves. Now let's talk about the actuators. The actuators here for air pressure, for a direct acting actuator, is that the air pressure comes in through this chamber above here. And this is kind of exaggerated because it looks like a great amount of space here as far as how it pushes down, but normally you may only get maybe 3/4 to 1.5 inches of travel as far as this airspace that's above here. But nonetheless, the air pressure pushes up here and builds up air pressure, pushes against the spring, and then pushes down to the stem. The stem starts to extract out. When that air pressure goes away, this spring pressure then starts to go back, and then the stem goes back up into the actuator, retracting the stem. Then from the opposite action is where the air pressure comes in underneath the bladder. And in this particular case, we can see that this air pressure is coming in underneath the air, and therefore the fitting that would be on the side of this actuator is physically further down from the top of this actuator. And you can tell often, as far as looking at those valve actuators, that this might be a reverse acting actuator. So their air pressure comes in underneath this bladder and actually stretches this spring. And then when the air pressure is released, then that spring returns back to its normal position. So once it starts to build up pressure, that stem is retracted and goes up into itself. And then once the air pressure goes away, then the spring returns back, and then that stem goes back out itself outside. So that's how you would actually see the operation of this direct acting or reverse acting actuator. Also in this picture here, it's maybe a little bit easier to see in the upper right-hand corner, the fitting that's attached to this particular actuator is above this round top, and therefore the air is being introduced into the top above the bladder. If there are some other ones that might be designed, it might come underneath here and then bring in the air pressure around or underneath the bladder. So just things to look for.
And the other neat thing about that picture is that you can clearly see the spring. Some actuators are fully enclosed. You don't actually get to see the spring. This one here is kind of neat in that you can see the yoke where it couples to the valve body. You can see the spring, and if you look up into the top part of it, you can almost see the actuator itself.